Hello and welcome back to another episode of Measurement in a Minute. I'm your host, Justin Kozak with Lakeside Process Controls. And in today's video, we're continuing our discussions around Rosemount and micromotion flow meter technologies. To do this, we're going back and reviewing some basics of fluid mechanics. Today, we're going to specifically talk about viscosity, what it is, and how it impacts flow meter technologies. So first of all, what is viscosity? You'll find many technical definitions out there. For instance, it's the measure of a fluid's resistance to deformation. Some like to think of it as the internal friction between the molecules, but I like to think of it as really the thickness of that liquid. So if we take a look at this example here, you have water on the left, let's say, and maybe honey on the right. You can see the difference between that thickness. And that's very important to understand, is that you have to move the fluid, you have to apply a pressure to it in order to see that difference in viscosity. So you can't just look at them to see the difference. It's that critical element of having to try to move it and then it resisting that movement. Now, if we do look at the technical definition, it's the ratio of the shear stress, and the shear stress is the amount of resistance to, applying that shear motion to it, over the shear rate. And the shear rate is essentially those adjacent layers, the velocity that they are moving across one another. And so there is your technical definition for viscosity, and this plays a very big role on the flow meter technology that you choose. For instance, if you have very high viscosity fluids like maple syrup, for instance, or toothpaste, you're going to have to pick an appropriate technology that can handle that. Should you have any questions about Rosemount or micromotion flow meter technologies or any other of our products, please reach out to us at www.lakesidecontrols.com. Thanks and have a great day.